Hey team, today we'll be adding and subtracting rational expressions. Before we get to two examples of those, I'm going to do a quick refresher on LCM, which stands for least common multiple. Because if you think about one example here, we have a 3 and a 4 and a 6, so you think, oh, well the LCM of that is 12, easy peasy, I'm done, I don't even need to do any work. Well, think about it another way. If I were to break 3 down to be 3 times a 1, 4 will be 2 times a 2, 6 will be 2 times a 3, so the prime factorization of all those numbers. Think about what they're missing. So at 3 we have 3 and a 1, but it doesn't have 2 number 2's, so it's missing 2 number 2's. Number 4 has 2 number 2's, but it's missing the 3 from both of these ones, so that's missing a 3. And 6 has a 2 and a 3, but it does not have an additional number 2. And so it looks like the prime factorization would be 2 times 2 times 3, which happens to be 12. And so that would be the LCM. You can think about it 2 times 2 times 3, or you can think about it as a number 12. That's another way to think about it. So we might need to use that in this example, because here they're saying we have a quantity of x squared plus 4x minus 12, and here we have x squared minus 6x plus 8. Well, hey, what's the LCM of these two things? Well, let's go ahead and factor it. So what multiplies to negative 12 and adds up to 4? Well, let's see. Looks like we have a 6 and a 2. Let's make the 6 positive, so it adds up to a positive, and then minus 2. Over here, it looks like we have very similar thing. We have x minus 4 and x minus 2. So if we think of it out in terms, they both have an x minus 2, but this expression on the left does not have an x minus 4, and this one on the right does not have an x plus 6. So the LCM would be x minus 4, x plus 6, and x minus 2, so it has one of every term. Okay, so keep that in mind. We'll need to use that when we add and subtract rational expressions. So let's look at an addition problem here. So we have 4 over x squared plus 3x plus x minus 2 divided by x squared plus 6x plus 9. Well, before we just start adding together and say we'll have like maybe 2x squared and 4 plus an x minus a 2 and combine our like terms. Well, one thing about fractions is we have to have common denominators before we can add anything. And so they have to be the same size pieces before we can add them together. Otherwise, we're not sure what we have if we're counting different size pieces. So let's go ahead and find any GCF or factor what we can. So up in our numerator is 4. You can't really do anything with a 4. You can't really do anything with an x minus 2, but you can have a GCF of x on the denominator over here. So we have 4 divided by x times x plus 3. And on the right side, again, you can't do anything with the x minus 2. But we do have, let's see what multiplies to 9 and adds up to 6. Looks like we have an x plus 3 times an x plus 3. Okay. And so we have to find the LCM. Well, this side over here is just missing an x, and the side on the left is just missing an extra quantity of x plus 3. So I'm going to multiply this by a 1. I'm not changing the value of it. I'm multiplying it by a 1, but my 1's going to look different. It's going to be x over x. And on the left side here, I'm going to multiply this by x plus 3. And I'm going to do that in the numerator and the denominator, so I'm not changing the value of the actual number. I'm multiplying it by a 1, but this is what my number 1 looks like. Okay, so from here, looks like 4 is multiplying x plus 3, so we can distribute that in. So on the numerator we'll have 4x plus 12. Over here the x is multiplying these two items, so we'd have a positive x squared minus 2x. Okay, before we write our denominator, let's go ahead and combine our like terms. So it looks like we have a 4x and a negative 2x are like terms, they can combine. And let's write it in standard form as well. So we'll have x squared plus 2x plus 12 divided by x times x plus 3 times x plus 3. And I don't need to write my denominator twice. This is our common, this is our LCM. That's what all the fraction will be over since they're all in that size piece. I could try and factor this. Looks like it's a quadratic. I can't think of any integers that would multiply to 12 and add up to 2. So let's go ahead and state our restrictions, which would be only two things. X cannot equal 0 here, and x cannot equal a negative 3. And so this is our simplified form, and these are our restrictions. Alright, let's take a look at a subtraction example. So let's say we had, let's say x plus 2 over x squared minus 2x minus x plus 2 over 2x minus 4. Okay, so same thing as before, we have to have common denominators before we can subtract fractions. So let's see if we can find any GCF or factors. So on top, x plus 2 will stay the same, but underneath, looks like we can take out an x, leaving you with x minus 2. Let's see, the top over here would stay the same as x minus 2, but we can take out a 2, leaving us with x minus 2. Okay. So x minus 2 is the same on both denominators. So the only thing missing on the right side would be an x. The only thing missing on the left side would be a 2. Okay. So on this right side, I'm going to multiply top and bottom by an x. On the left side, I'm going to multiply top and bottom by a 2. So you notice our GCF, or our LCM, our denominators are now common. We have a 2 in x and the quantity of x minus 2. We'll have the same thing here. We have a 2 times an x times an x minus 2. There are now common. So, if I were to put this in parentheses, this 2 would be multiplying the x plus 2. So we end up having 2x plus 4. And on the left side, we have to be careful here because this x plus 2 is being multiplied, yes, by this x. It's also being multiplied by this negative value. So it's like we have a negative x minus a 2. And all of that's being multiplied by our x, leaving you with a negative x squared, when you multiply this one, times a negative 2x. And before I write the denominator, let's go ahead and simplify this up. So we have negative x squared. Let's see, 2x minus 2x goes away, plus 4. Okay. And let's see, let's keep breaking this down. If I were to take out a negative 1, that would leave me with a positive x squared minus 4. Well, that actually is factorable, leaving you with negative 1, x minus 2, and x plus 2. When you factor that, all of this will be over 2x times x minus 2, our denominator from above. Well, if we're looking for any restrictions before we look to cancel and simplify, we have to state our restrictions. So, looks like x can't be a couple things. X cannot equal a 0. If I plug in a 0 there, that means we're dividing by a 0. That's no good. And the other restriction would be a positive 2. That would make the other term 0. So x cannot equal a positive 2 or a 0. So now we're left to simplify. So x minus 2 would cancel the x minus 2, leaving you with a negative 1 times x plus 2 over 2x. Alright. So there you have it. That would be the simplified form with your restrictions right there. And so if we add a step-by-step basis, you kind of want to think of it, 1, find the GCFs, or factor what you can. 2, find the least common multiple, so you have common denominators, right? Common denominators. Step 3 is when you want to state your restrictions. And once you state your restrictions, then you can go ahead and cancel anything that cancels and simplify your expression. And there you have it. And that is how you add and subtract rational expressions.